Hello, my name is Talia. Welcome if you're new, welcome back if you're not. I'm a third year student at UC San Diego and I study chemistry and minor in science education. I made this YouTube channel to be a supplemental resource to anyone studying chemistry. In this video, I'm going to be talking about different kinds of nuclear radiation, alpha, beta, and gamma, and we're also going to be doing some practice problems and also doing a little bit of an informal intro to nuclide symbols. So if you need help with any of those topics, keep on watching. And without further ado, let's get started. Okay, so as always, I'm going to be looking at the slides on my iPad, but they are screen recorded, so you should be able to see them on your screen so that you can follow along. So before I get into talking about the different kinds of nuclear radiation, you're going to see me represent a lot of things throughout this nuclear chemistry unit with nuclide symbols. And I wanted to go over what a nuclide symbol is. So they will usually represent either a kind of nuclear radiation or an isotope of an element. In this slide, I am using carbon as an example, and the symbol has three parts. On the right side, we have the atomic symbol. So carbon is C, that's why I have that here. And then on the left side, we have two numbers. On the top is the atomic mass of that isotope. So carbon 12 has an atomic mass of 12 atomic mass units. And then on the bottom is the number of protons. So carbon has 6 protons. So this kind of gives you all the information you need to know about an isotope when it's undergoing nuclear radiation. And we will use these nuclide symbols in nuclear reactions, either when you're given an isotope and you have to figure out what will remain at the end of the nuclear radiation, or sometimes you'll be given the product and you have to determine the starting isotope. So there's a lot of different ways we can play around with these nuclide symbols, and we will get into that in future videos. Okay, so I wanted to go over the three kinds of radiation, alpha, beta, and gamma radiation, and explain what kind of particles they all produce, and then we're going to get into their strengths. So first we have alpha radiation, which produces alpha particles. So an alpha particle has the same structure as a helium atom. So we represent it with a nuclide symbol of helium, which has an atomic mass of 4 and 2 protons, and then the symbol for helium is He. Next, we have a beta particle, which is produced from beta radiation, and it has the same structure as an electron. And this beta particle forms when a neutron splits into a proton and an electron, and the electron part is emitted. Therefore, it has the same structure as an electron. So if we look at the top and the bottom numbers, an electron doesn't have a mass, or its mass is basically 0. And then an electron has a number of protons of -1, because one proton and one electron, their charges together will make a neutron. So when an isotope undergoes beta radiation and a beta particle is emitted, nothing happens to the atomic mass. All that changes is the number of protons. Versus in an alpha particle, both the number of protons and the atomic mass is going to change, because an alpha particle is the structure of helium, which has both an atomic mass and proton. So finally, we have gamma radiation. Gamma radiation emits a gamma particle, and a gamma particle doesn't have protons or an atomic mass. All it does is bring an element from its excited state to a ground state. All right, so now we're going to talk about penetrating power, which is basically fancy terms for the strengths of the different kinds of radiation. So the strongest, which you see on the bottom, is gamma, and then beta is the next strongest, and then alpha is the weakest kind of radiation. So you can see what each kind of radiation can be blocked by. Okay, so now we're going to do some practice. The first fill in the blank, you're going to fill in the blank. So the strongest kind of radiation is what kind. And then in the second and third problems, I've shown you what a nuclear reaction practice problem might look like with the nuclide symbols, and you are going to identify the kind of radiation that I'm talking about based on the highlighted boxes. So figure out what kind of particle that symbol represents. So take a minute to work on those 3 problems on your own. Okay, let's go over the answers. So, first we have that the strongest kind of radiation is gamma radiation, which you can see back here. Gamma radiation is blocked by 1 centimeter of lead or 6 centimeters of concrete and goes through paper and aluminum foil, which alpha and beta radiation is blocked by. This second problem, it should have said alpha particle, but the symbol with 4 atomic mass units and 2 protons and then helium, that is alpha, that's an alpha particle. And then finally, 0, -1 electron, we know that that is a beta particle. All right, that was the end of this video. Next time, we're going to be talking more about nuclide symbols and nuclear radiation. We're going to get some more practice in, so I hope you'll join me back if you would like some extra help. I hope you enjoyed this video. Feel free to leave any comments or questions in the comment section below, and I look forward to seeing you next time. Good luck with learning your chemistry.